Okay, welcome to this video. What we'll be looking at firstly is some definitions and with the explanation. So the first one is the theorem of Pythagoras and the statement of the theorem. Now, a theorem is a statement, and it's a very precise statement. It says, in any right angle triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. Now, hypotenuse, don't worry what that means. We will look at it now. And then we have a triangle, and the definition of a triangle is a three-sided closed figure. Then we have a hypotenuse, which is the longest side in a right angled triangle. Now, not just any triangle, but a right angled triangle. So that's very important. And even in the theorem itself, it basically does state in any right angled triangle, and not just any triangle like an isosceles triangle or an acute triangle or anything else, right? It says a right angled triangle. So this should tell you that the only time you use the theorem of Pythagoras is when you have a right angled triangle. So you need to be able to identify a right angled triangle. Now, it is opposite, so the hypotenuse is opposite the right angle, and I'll show you how. And then we have a square to multiply a number by itself, right? Which is 5 times 5. But in this case, we would usually write it as 5 squared, right? 5 squared, right? And that's what we mean by square, 5 to the power 2. And then square root is when we square root, like 25. The square root of 25 is 5, yes. Sum of means the addition of. And you heard here it says the sum of the squares, meaning of the two sides, meaning there are two sides that are being squared, but also they are being added separately together, right? And this is what you find, that there is two sides that are squared, but they are being added together to give you the hypotenuse. But let's go over it again. So the theorem of Pythagoras states that in any right angle triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. If the two sides are known in the right angle triangle, it is possible to find the other sides using the theorem. So if you just have at least two, whether it's B and C, or A and C, or A and B, you are able to find the rest of the sides. And this is a right angle triangle. Now, another thing that the definition of a hypotenuse said is that it's the longest side of a right angled triangle, and it is opposite to the right angle, right? Where is the right angle? Here is the right angle, right? This is the right angle over here. And notice something about this right angle, that it is exactly opposite. In actual fact, the corner of the right angle is almost pointing to the hypotenuse. So that's a very easier way of looking at it and being able to identify what your hypotenuse should be. Okay, so it's actually literally pointing at the hypotenuse if you look at it, right? So as you can see, then you have your two sides, which is A and B, and it doesn't really matter the order in which A and B is done, but yeah, okay, but it's very important for you to identify the hypotenuse correctly. So a quick example is that if we have a right angle triangle where you can see the right angle is pointing towards the hypotenuse, which should, yeah, that would mean that the hypotenuse is AC, right? So therefore, the other two sides will be AB plus BC. And then you must write a reason in this case where you say it's Pythagoras. I didn't write the full name, I just say Pytha dot. You would write the full name Pythagoras. And so you would know that, okay, it's Pythagoras, and then you substitute your numbers. So it will be 6 in AB, it will be 8 in BC, and then you have 36 plus 8. 36 plus 8 is actually equals to 100. But then to get AC, you need to square root both sides, and then you'll get that its AC is equals to 10 units. Now, I said units because these this is some type of length, but we not say, they didn't say how long it is, but you just rather say it's units because it's some type of length. It's not just a number, it's not just a random number. Okay, so and then we look at this one where we have QRP. Now you see why it's quite important for you to be able to identify the hypotenuse correctly. It's because they will give you cases where the triangle or the right angle triangle will be placed in such a way that it won't be easy to just immediately see what is the hypotenuse. So you need a guiding principle, and the guiding principle is that it is always opposite to the right angle. And you, as you can see, there's the right angle there, and the right angle at the corner, it's literally pointing at the hypotenuse. So this is the hypotenuse, which is RP. So RP is the hypotenuse, and then you have two sides, which is PQ and QR, right? And again, you write the the reason that it is Pythagoras, and then you substitute your values. Since you know RP, you put RP 13 in the place of RP, so it's 13 squared, and QR, you know that it's 12, so it's 12 squared, and then you take 12, you subtract it on the other side, so you are actually solving for PQ. So when you're solving for PQ, this is how it would happen, and then you get to your answer that it is 5 units. Okay, so that's very straightforward. But now, this is actually a question that I want you to think about. Now, what if you have this triangle where it's A, B, C, and then they ask you, is it a right angle triangle? Because now they did not place any right angle here. They didn't show us if it is a right angle or not. But they are asking, is it a right angle triangle? And how would you prove it, right? How would you prove it? So the proof, to prove it, you need to prove that AC is equals to CB plus BA squared, right? Which is the theorem of Pythagoras, right? So you need to prove the theorem of Pythagoras because you don't know if it is a right angle triangle. So just imagine they gave you 3 of the lengths. They gave you 3 of the lengths, and then they said, is it a right angle triangle? Then how do you show that it is a right angle triangle correctly? Because you shouldn't just look at it and say, no, this is the right angle triangle. But what is your proof? So this is your proof. This is your evidence. Yes, you can see it, but now this is your evidence to the fact that it is a right angle triangle. So you would use the theorem of Pythagoras, and the theorem of Pythagoras basically says if AC squared is equals to CB squared plus BC squared BA squared, that means in actual fact that that particular triangle has to be triangle ACB is a right angle triangle. It has to be a right angle triangle because this only works for right angle triangles, remember. And that's what the theorem basically said at the beginning. It said in any right angle triangle. And as I said again, if it tells you that it's a right angle triangle, it means that it just can't work for just any other particular thing. So if we tried it with any other type of triangle, this would not happen. And what you would find is that whatever you a squared plus b squared would not be equals to c squared. But if it is a right angle triangle, then it does mean that a squared plus b squared will be equals to c squared. Okay, so how do you prove that? So we show it by saying we have AC, and AC here is 5, so we say 5, and that gives us 25, right? So that gives us 25. You can see that is 25. And then we take CB squared plus BA, which is the second half. So this is the right hand side, so I took the right hand side on separately, and we got 25. And then I took the left hand side separately, and we substituted everything, and we got 25 again. So now what does it tell us? It tells us that the right hand side is equal to the left hand side, which is 25 is equal to 25. So that means that AC squared is equal, because remember AC squared is 25, is equals to CB squared plus BA squared, which is also 25. So it holds. Therefore, that means the triangle ACB is a right-angled triangle. And that is your proof. And that is your proof. Therefore, now you have shown without a doubt, with evidence, and you saw that it was a right-angled triangle, but with evidence, without a doubt, you have proven that in actual fact, this is a right-angled triangle. And then the last example here, you would find that they would say, find AC. Now, where is AC? AC is this long one over here. But now the issue is, you don't have BC. So how can we get BC? If you notice, there's a triangle in the center first, in the beginning part here, right? Where you have DC and DB, and then you're looking for BC. So in triangle BCD, you use the theorem of Pythagoras, and you get that BC is actually equals to 12, right? And then since you've gotten that that's equals to 12, then you want to find, obviously, your AC of the bigger triangle. But the bigger triangle, notice that BA, or A to B, it's 5 plus 5, which is 10, right? And so you have 10, and then you already got CB, which is 12, and then you actually find that it is 15.24 units. Okay, and then lastly, I'd like for you to try out this particular question here. So this question here is just for you to try it out on your own, but if you have any problems, please feel free to ask questions to the person that is helping you, and also you can also send the question through to us. Other than that, I really hope that you enjoy this last question on your own. I'll not post the answer unless someone asks what is the answer. But other than that, I really hope that this was enjoyable. I hope this was helpful. Other than that, I'll see you next time. Thank you. Goodbye and good luck.